Yes.
Is that what is on their quiz tomorrow?
Damn it, I have to write you another quiz.
Yeah, you don't have to.
You don't have to.
Yeah, but if I don't give you 5 quizzes, then I don't have one to drop. Well, okay, actually I very specifically do weighted grades and not like total points, because I can do stuff like that. I can go, we're gonna have 4 quizzes and drop the lowest one. And it doesn't affect, like, your end points or whatever. Like, the category is still weighted the same, so. No, I'll give you guys, I'll write up a quiz for tomorrow, and, like I promised, I'm not gonna quiz on anything that you learned the day before your quiz. Definitely not the day of. I won't quiz on anything you learned the day before the quiz, which means that,
It's just Monday and Tuesday.
yeah, basically we did hemiacetals and acetals on Monday, mostly, and then Tuesday we did alpha, carbonyl, alpha, hydrogen chemistry, yeah? That's what we did, right? It's gonna be those. And, if everyone's cool with the length of that, I asked this like at the beginning of class and everyone was here, which is totally fine. Totally okay to be late. I don't take that personally. I would be late if, well, I have been late to a lecture before, but only once. No, actually it was allowed. I was still the instructor governor, but it was allowed. But anyway, if anybody wasn't here this morning when I asked, I got a consensus that we were okay with the length of the quiz. Give me a firm no shake of the head if you disagree with that consensus that I got earlier.
I think
Okay.
it was fine. He just needs to watch his time so he doesn't go over and we get our full time.
Okay. So we can switch it so that you guys get the quiz first. Wait, did you have the quiz first? No, you didn't have the quiz first. We can switch it so you guys get the quiz first. That way you definitely have all your time, and I don't know, I used to do, I don't know, I was in the habit of always doing quizzes at the end, because that's how Dr. Waddell and Dr. Padolik had us do it, but also, we would generally have things on the worksheet, or they'd have questions about the type of stuff that's about to be on the quiz. But since you guys have open book, and I'm not trying to make it a race against the clock, hopefully it doesn't feel that way. If it does, let me know. Yeah, so I can tell them to do the quiz first, if you guys are okay with that, if you wouldn't rather have some time beforehand. Do we all for quiz first? All for quiz at the end of recitation? All for give us 10-15 minutes to ask questions and stuff and study, and then do the quiz, and then do more working on stuff after that? Okay. One of the latter two then. So, I guess you guys didn't know that the last option was there when I asked the first two, but it seems like most people don't want the quiz right when you get there.
I think cutting down the number of questions will significantly help the time crunch.
Okay.
Because part of it was just he would give us basically 20 minutes to do the whole worksheet, which was 10 problems.
Yeah.
And then explain it for 40 plus minutes.
Okay.
People would just ask him really easy questions, or not easy, but stuff in the slides that's clearly labeled, and then he'd have to go through and explain it all.
Well, and he
Yeah.
doesn't, he doesn't attend lecture, because I'm not gonna do that to my TAs. When I taught, recitation for, exactly this class, actually. Yeah, it was Organic 2. Organic 1? I think it was Organic 2. And I needed a whole shawl in that class, because we had to go to lecture in person, because it wasn't recorded. So I was I got the worst TA thing. I have to show up to the 8 a.m. lecture. But I got so much knitting done, and I hung out in the back and, I don't know, got to answer questions quietly.
Yeah, I agree with what he said. He had explained the same thing like 3 or 4 times.
So if we cut these worksheets down to like 3 to 5 questions max, and then you've got plenty of time to, like, with the assumption that you're gonna have extra time probably in your recitation that just doesn't have anything to do, but hey, now you've got book homework that's not fighting with the computer online homework, and maybe hopefully that's a lot more helpful, so we can work on that, yeah?
Also, I don't know if like maybe you already do this. Given that like we've changed how much content we've covered in class, it might be helpful to keep the TAs updated with kind of our pace. Because like he included reduction questions on
Yeah.
yesterday's worksheet kind of
Yeah,
thing. So like
fair.
the questions that we do have are things that we can answer, and then we will have less
Yeah.
questions because we will have already covered them.
Totally
in
fair.
lecture.
And also, like, if there's stuff that you start doing in recitation, so like, I want them to make their worksheets ahead of time, which means that I am giving them like, here's where I think we're gonna get. And I try not to be too optimistic, but I think I'm really, really optimistic at heart about how not slowly I'm gonna do, or how much time I'm not gonna spend just not lecturing and talking about how this class is gonna go. It's fine. I just wanna make sure that this discussion is useful, right? It's helping us learn, we're making choices that are not overwhelming you. Okay, I'm not just entirely wasting time.
My only other concern about doing the quizzes at the beginning is if you need the extra time.
Oh, yeah, duh, okay, yeah, no, so quizzes need to happen at the end. I'll just,
The time issue we completely solved though with the worksheet
Yeah.
was cut shorter. The
Okay,
worksheet's
yeah.
so thick.
Cool.
But like you said, cause they don't know our pace in lecture, if we can just go over with them in the beginning and like not do the questions that we don't know.
yeah,
that would
I
be
mean,
the worksheet.
honestly, you very much can, so like, yeah, you guys can, you know, not ask questions on those ones and just like,
And we can just, like, stay
yeah, I can just talk to them about like, yeah, I can just have them like, if you make, you know, I'll ask them to make like a backup question or two in case we have to get rid of more. You know, if we have like a 3-question worksheet, we get rid of 2. No, we'll do 3 to 5 question worksheets and I will have them make it,
If it's any help, like last term's worksheets were usually front and back 5 questions. and
okay,
it
that's
was
that.
fine.
Okay,
It was fine.
cool.
Yeah.
Um,
How many pages did we have yesterday, front and back?
3, but the formatting was weird.
Yeah, 3, but like 1 came up.
But there were like 10
There were
questions.
non-super
Yeah, I
questions.
saw the 10 questions and like, I know, like, trust me as a TA, it feels like I've gotta do, like if I do 3 questions or whatever, then it's gonna look to the, you know, instructor, professor, like I'm not trying very hard and like, you know, there's, like as a TA, you wanna make a bunch so that like, you guys won't get bored and here, we can go over some of them and then whatever we get to, and if you don't finish it, who cares? At least you didn't all finish it early and then you were bored for the rest of it. But yeah, I think this way is gonna be better. And since I explicitly told them to do 3 to 5 questions, they won't feel like I think they're lazy. And you've got something else to work on after. Okay. Okay, yeah, so quizzes at the end still, but hopefully we can set timers or have them set timers and the plan is still keep your quiz, like, tell your TA, hey, I have extra time, keep your quiz with you, bring it up to Regashul, 8th floor, and come find me for extended time things. Yeah? Okay. If you have extended time on exams, that's the plan if you're not taking lab right now. If you have extended time on exams and you are taking lab, email me, and we'll figure something out. Okay.
I think she let them start early last. But
Fine, okay. That's an option. If you are taking lab and you also have extra time, that is one of the options. There are other options, so if you are willing to get here early, then I'll do that. Yeah, that's fine. I will do that. I won't be very awake, but I won't have to teach, so it's fine. And I won't hold it against you personally. So, yeah, that's an option. There will be other options, so you don't have to just either get up ridiculously early or take your extra time. Those are not the only 2 options, because that is oxidized by chromic acid or potassium permanganate. So, we didn't talk about potassium permanganate, but I guess that's a common oxidizing agent. I assume it oxidizes alcohols, or maybe, and or like double or triple bonds or something, maybe, something like that. Okay. Some of those, you should know, so you should go through the oxidation and reduction and reducing agents that we go through on this. You should go through those and like make a chart of all the things from first semester that will or will not be oxidized or reduced by those. Because as much as like, I don't want to do a whole lot of multi-step syntheses where one of the steps is like, oh God, like the first thing we learned in first semester, and that was so long ago. I mean, it's not a semester ago, it's like a month ago, but it's a very dense month ago, or month and a half or whatever. So, but with these guys, that's like a really important part of it, knowing which ones are safe to use, like which ones will ignore the functional groups you want to ignore, or if you need to use protecting groups or whatever. So that's the thing you should make a chart on. And if someone makes a nice, fancy, or convenient chart and wants to post it on a discussion board, then you all have it. Okay. Ketones, they undergo oxidative cleavage via their enol form. So, when they're treated with strong oxidants at higher temperatures and higher concentrations of acid or base. So, excuse me, you need strong oxidants, you need to heat the crap out of it, and you need not just like a tiny little catalytic amount of acid or base, just put all sorts of it in there, why not? And I'm not gonna, okay, yeah. So, it does this, and then what you're gonna do is end up breaking right here. Yeah, that's the one you're gonna break. Yeah. Yeah. So, I mean, this is symmetric, so I don't really like when they give me this is the only thing, and I don't have like more of these. We go on to reduction. I would like the example to have everything in there so I can tell you, but I think what's gonna happen, and you'll have plenty of things in your homework questions for this, so, and I can find out later and you can come to office hours for these. But it basically, you end up deprotonating that, or I guess protonating this guy. You have keto-enol form. Even if most of it is in the ketone, you always have a little bit of that equilibrium, right? So even if there's just a tiny bit of this, if this one reacts into something else, then your equilibrium is going to be constantly making a tiny bit more of this, and eventually you'll get a reactant. So it goes, the enol form is what reacts, and it cleaves right there, and you get a carbonyl where you had it, and 1, 2, 3, 4, 5, 6, 2, 3, 4, 5, 6. Okay, yeah. So you keep the same number of carbons, you just end up doing so much oxidation that that ketone that turned into an alcohol became a carboxylic acid, but then also the other carbon. So I break it there. Yeah, no, I'm crazy. You don't break it here because this, I was thinking you break a single bond, it's easier to break, but this carbon has 2 hydrogens on it. So it's tetrahedral. So that's not what you want to end up with. So I suspect you break this one. I'll look at that on your homework, or somebody tell me if I'm right or wrong on that on your homework.
I think
But
when we learned about that, like, general oxidation in the past, you always broke the double bond.
okay, cool, good. Oh yeah, because you just these electrons go grab something and this comes in, or it flips out or something. Yeah, okay, yep. Thank you. That is helpful because why make it symmetric when I'm gonna have to have this thing You know what I mean? Like if this isn't symmetric, then if these two carbons have different numbers of substituents, then one of them's gonna be favored, and you're gonna be able to tell me which product in the end is favored. So yeah, double bond breaks, and pay attention to whether one side or the other of your enol is favored. If this is asymmetric, but like we've got a methyl group down here, that doesn't affect which side is more stable, right? So in that case, 50-50-ish, random mixture. But yeah, so when we break this, we end up with 3 molar equivalents of oxidizing agent, not oxidation agent. You have question face.
No, I'm
Okay, cool. That's fair. Yeah, so turn this into your enol form, figure out if it's symmetric, so there's only one form, if it's asymmetric, so there's 2 forms, and if it's asymmetric, is one of them more favored than the other, or is it just asymmetric somewhere else where it doesn't matter and that's not helpful to us? Which means we'll get product, but like then we've got to run a column, and the column is going to be really annoying. And then you break the double bond, and you turn both of those carbons that were already there into carboxylic acids. This is for something like this, it's a really good idea to, if you've got multiple colors, like scribble a color right on that carbon and scribble a different color on this carbon, so that when you break bonds and then you start doing this, and then you start counting like how many lines you make, but you've got extra lines because now you've got an OH at the end of them. Count your carbons on these, because that'll, yeah. I mean, I guess sometimes you'll have 2 carboxylic acids rather than just, a ring that opens, but yeah. Yeah? That makes sense? Sorry. Last year I studied these slides right before I taught them. And this year, I think I know them well enough to pretty much teach without excessively studying. And also, I didn't finish my dissertation before the class started, so I also have to work on writing stuff. Because last year when I taught this, I just told my advisor, I'm not gonna be a student for the whole month that I'm teaching this. And I was not. This time I'm trying to get out of here. So I'm sorry. So, reduction. Aldehydes can be reduced to primary alcohols. Ketones can be reduced to secondary alcohols. So, to remember just one rule instead of 2 sentences that you're trying to remember, take an aldehyde or a ketone and reduce it to an alcohol. And, you'll figure out if it's primary or secondary after you draw the alcohol that you would get, right? Because there's just one carbon group over here. Once you end up drawing it, you'll be like, oh, okay, yeah. There's not another R group, so I guess that's a CH2OH, and that must be a primary. But yeah, those are the things that I don't like to memorize. The CO group of an aldehyde or ketone can be reduced to a CH2 group. So you can reduce to an alcohol, or you can do extra strong reduction to just, you know what, all the oxygen's gone, reduce all of the oxygens that had been there to 0, and it's just CH2. So, you're turning that carbon into a CH2. So in this case, it's a CH3, but one of those hydrogens was already there. You know what I mean? So I don't know. But you're just turning it into a normal alkane, basically. So we can do metal hydride reductions. Sodium borohydride and lithium aluminum hydride, LAH, or LiAlH. I've seen it written both ways, but chemists are inherently lazy, so LAH. Basically what both of these are is a hydride ion, because if we tried to make this, hydrogen exists, I mean, I guess very briefly it could exist as a radical, just as like, just an atom would be like a radical. I guess very briefly you could get that if you radically cleaved diatomic hydrogen. But like the way it normally exists is either diatomic hydrogen or H+, right? So you do this and it's not gonna want to live like that. So you have to attach it to stuff like this, and that's the way that you get a hydride. So then we have a hydrogen that is a nucleophile. So, yeah, and their derivatives. Reductions with NADH4, that's, okay, yeah, NADH4 and LAH. Reductions with NADH4 are usually carried out in aqueous methanol or in pure methanol or ethanol. 1 mole of NADH4 can reduce 4 moles of aldehyde or ketone. So, I don't know, 1 mole of NADH4 is 4 moles worth of reduction. There, 4 moles worth of reduction. And NADH4 is going to reduce you to an alcohol, and I bet when you did your alcohol chapter, you didn't learn about NADH4 as something that can reduce an alcohol because, well, it doesn't seem to be able to, because if you reduce a ketone or aldehyde, you end up with an alcohol, and there's still extra reducing agent, and it doesn't do anything after that. So NADH4 will reduce you halfway, just to your alcohol. There you go. Ooh, okay, yeah. We get to do this as a mechanism. Why not? All right, sure, we're gonna do this as a mechanism, but then